Dear students, we are in Continuity and Differentiability chapter, class 12 NCERT. Okay, last two classes we have seen already what is continuity and all. And continuity only we are seeing. Differentiability we have not yet seen. Okay, continuity we have to finish 5.1 exercise. And we have seen how continuity will be checked with the limits, and what is algebra of continuity, and what is continuity of functions, and all we have seen. Okay, different type of functions. We have seen graphs also. Okay, based on this experience we can start exercise 5.1. In exercise 5.1 we will do all the questions. 34 questions are there, and sub questions also there inside, again A B C D, like all. If you do these questions, automatically you are going to get the full conceptual knowledge of about this continuity. Okay, let us proceed and take first question. See, exercise 5.1, first question. Prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3, x is equal to 5. Okay. Now, by seeing this itself, we can say that not only at x is equal to 0 or minus 3 or 5, whatever it may be, this function is continuous, like we can say. Why? Because there are no conditions. See, what I want to say, if f of x is like this, 5x minus 3, when x is greater than 3, and 5x plus 3 when x is less than or equal to 3, if like that some conditions are there and function changes according to the limit domain. See here, these are domains. Input means domain. Domain, if less than or equal to 3, give 5x plus 3. Greater than 3, if you give 5x minus 3, then the function is going to become discontinuous here in this case. But like this case is not there here. This is a simple case. A simple case means this is continuous only. But even then, first question for x is equal to 0 we will do as per procedure, full length. Second question onwards we will reduce some more steps. Third part onwards we will reduce some more steps. Why? Because those steps are not that much required. But why I am writing all these steps? Because you have to understand the concept clearly, very clearly. Okay. In the next 5.2 concepts, then this continuity is there, then only differentiable function like it will come. If continuity, if you don't know, then you cannot understand about differentiability. That's what I wanted to say. Okay, let us proceed further. We will see. Goes on, we will reduce the steps. Okay, those much steps are not required. And one more question. Depends on the marks of the question you have to proceed. See, these are objective questions, means you can say by seeing itself this is continuous. Objective type question. There they don't see your rough work, what you have done and all. But if this comes for larger questions, larger marks, then you proceed all steps. If these questions come for less marks, then you reduce the steps. Okay, that you will get by experience. Okay, okay. Let us proceed. Okay, see this function. First, we will see the continuity at x is equal to 0. Okay, I am seeing, you see, continuity of the function at x is equal to 0. Okay, at x is equal to 0 I am checking the continuity of this function. Okay, see how I am checking. Okay, limit x tends to 0. Why? Because 0 we are checking means 0 only, f of x, that is equal to limit x tends to 0 sorry, not 0 minus 0 only you have to write. 0 only you have to write. And f of x means what here? 5x minus 3. Now apply limit. Substitution is going to be called as apply limit. X 5 into 0 minus 3, that is equal to minus 3. Is it okay? Why? Because 5 into 0 is 0, minus 3. Minus 3 has come. Okay, now you tell me here Even you can write like this also. This is limit f of x is equal to 5x minus 3 comma f of 0 is equal to 5 into 0 minus 3, that is equal to minus 3. Now you can write f of x is equal to limit x tends to 0 f of x. Therefore, the function is continuous. Okay, this also you can write, but this is one process. I don't know, depends on examiner, they are going to give marks. Why? Because see, simple function is there means normally f of x is equal to limit x tends to 0 f of x only will come, and you see f of x also same minus 3 has come, limit x tends to 0 f of x also minus 3 has come. Okay, at the time we can say this function is continuous, but in long procedure, if it comes for higher marks, what you have to do, left hand limit, right hand limit of this function you have to find. Why? Because when left hand limit, right hand limit you find, if any variation is there, then values are going to vary. If not vary, left hand limit, right hand limit both are same and that equal to this main limit, then automatically you can write function is continuous. Like, okay, let me write how I am writing. You see, left hand limit comma limit x tends to 0 minus f of x is equal to. Now you tell me, are there any conditions for 0 minus 0 plus? Not there. Not there means you need not find, but you write, but you need not find. Directly you apply, you write this value, minus 3. Do you understand why I have written directly minus 3? Because there is no conditions like this. Limit x tends to, sorry, f of x is equal to, say, 5x minus 3 when x is greater than 3, 5x minus 3 when x is less than 0 equal to 0, like that. These conditions are not there, these conditions here. That is why here left hand limit directly you can write. Why? Because see, left hand limit, whatever the central limit say, but even then you have to write, then only you can say that this function is continuous, like, or else how you prove? Okay, write down like right hand limit also. Right hand limit comma limit x tends to 0 plus. Why? Because at 0 we are finding continuity of the function at x is equal to 0. 0 plus of f of x is equal to minus 3. Okay. Now left hand limit is equal, right hand limit is equal to, this limit is equal to all also you can write, or else simply if you want to skip the procedure for small marks, directly you can write by above we confirm the function is continuous at x is equal to 0. See, he asked us to find at x is equal to 0, but not only at x is equal to 0, at any value, real number, this function is going to become continuous. That we know. But as per procedure, this you have to follow. You see here, this procedure also correct. Limit x tends to f of x you find, and f of x also you find. If both are comes means same, then you can write the function is continuous, like both are equal. F of x is equal to limit x tends to 0 f of x. Okay. F of x or f of 0, I think here. F of 0 you have to write. F of 0 is equal to limit x tends to 0 f of x, that is equal to the function is continuous. This also you can write. Or else you write this. After this, left hand limit, right hand limit, then by above we can say that the function is continuous. These are also correct. Okay. Yeah, this is gross root level procedure. Like with this procedure, you can find very clearly. function. Why? Because left hand limit, right hand limit, if you apply, automatically you came to know. You see left hand limit also minus 3, right hand limit also minus 3, both are okay. Then you see compare with the main limit. When 3 are equal by above, we can confirm that function is continuous at x is equal to 0. Why? Because I don't know how many marks. If only this question is for larger marks, then you write all as per procedure. Okay. Let us proceed for x is equal to minus 3. Why? Because we know that this is continuous at x minus 3 also, 5 also. Okay. Let us proceed. Now write down limit x tends to 0, x tends to minus 3. Okay, write down limit x tends to minus 3 f of x is equal to limit x tends to minus 3 5x minus 3. That is equal to, you apply limit 5 into minus 3 minus 3 minus 15 minus 3, that is equal to minus 18. Is it correct? Minus 3 means minus 15. Yes. Minus 15 minus 3 minus 18. Okay. Minus 18 has come. Okay. Now, see, without applying, simply you can write left hand limit is equal to minus 18, right hand limit is equal to minus 18. Therefore, the function is continuous. Write down. Left hand limit, comma, limit x tends to minus 3 minus f of x is equal to minus 18. Why? Because need not substitute again. We know that minus 18 only is going to come. This you write. Next, what you are going to write? You are going to write this. Right hand limit. Limit x tends to minus 3 plus. This is at minus 3, this is at minus 3 minus, this is at minus 3 plus. F of x, that is equal to minus 18. Why? Because this also you need not find. We know very well that this same is going to come. Okay. Now you write. What you are going to write? By above. Write down. By above. Why? Because see, if these are for higher marks, then you have to write left hand limit is equal to right hand limit is equal to main limit. Therefore, the function is continuous. Like now, simple itself by above, you can write like this. By above, we confirm the function is continuous at x is equal to minus 3. Understand now? Okay. Like this you write and close. Now you see you have reduced the steps. This procedure only we will follow. Why? Because if like this simple function comes, there is no logical controls. X is less than 0 is this one, x is greater than 0 is another function, like that. Logical controls are not there. Simple function is there, means like this we will write. We will take one limit, remaining two limits without taking we will write copy, and we will write by above. We confirm that the function is continuous. This if you follow, full marks will come. No marks are going to be deducted. Okay. Let us proceed for x is equal to 5. Same thing. Okay. Continuity at x is equal to 5. Okay. Okay. See what I am writing. You apply limit at x is equal to 5. Limit x tends to 5 f of x is equal to limit x tends to 5x minus 3, that is equal to you apply limit now. 5 into 5 minus 3, that is equal to 25 minus 3, that is equal to 22. Is it okay? Definitely okay. Okay. Now you tell me 5 minus 5 plus, if you apply, same 22 is going to come or different is going to come? Same is going to come. Then you need not apply. You simply write left hand limit is equal to, like, write up left hand limit comma limit x tends to 5 minus f of x is equal to 22. Okay. Next, write the right hand limit also. Right hand limit, comma, limit x tends to 5 plus. Why? Because see, limit extends to 5, limit extends to 5 minus limit extends to 5 plus. F of x is equal to 22. Okay. See, all three are same. Then what we can write? We can write like this. The function is continuous at x is equal to 5. The function is continuous at x is equal to 5. Why? Because we have confirmed by seeing this. So all limits at all limits, that means left hand limit, right hand limit, main limit, all are same at x is equal to 5. That is why this is continuous at x is equal to 5. We have confirmed. Okay. Like this we can write and close this question. Let us go for second question. Okay. Okay, see. Examine the continuity of the function f of x 2x square minus 1 at x is equal to 3. Okay. Now also you can say that simply by seeing itself, it is an objective question, we can say that x at x is equal to 3 continuous. Definitely it is continuous. Why? Because see, there is no logical controls. Less than 3, one function, greater than or equal to 3, another function, like that controls are there. That means then we can check and we will see whether the same is coming or not. At the time also we cannot say that this is not continuous, but we have to check. But this without checking also we can say that this function is continuous. But even then, let us proceed further. Okay, let us proceed further. See what I am writing. See, now at only one area they are asking, that is why you need not write again at continuity at x is equal to 3, but you write down limit x tends to 3, f of x is equal to limit x tends to 3, 2x square minus 1, that is equal to, you apply now, 2 into 3 square minus 1. 2 into 9 minus 1, that is equal to 17. 18 minus 1, 17. Okay. Now you tell me, left hand limit I want to write 3 minus, whether same value is going to come or another value is going to come. Why? Because there is no logical controls. Directly, you need not to do. Okay. You see how I am writing? Left hand limit, comma, limit x tends to 3 minus f of x is equal to 17. Is it correct? Definitely correct. Why? Because there is no logical control. The same value is going to come for 3, 3 minus 3 plus, that's all. But for procedural sake, we are writing and we are confirming the procedure. This is continuously. Okay. Let us write right hand limit. Right hand limit, comma, limit x tends to 3 plus f of x is equal to 17. Okay. 17. Okay. Now you tell me at 3 areas the same value has come. This function is continuous or not? Continuous only. Right down. By above, we confirm the function is continuous at x is equal to 3. Why? Because he asked us to find at x is equal to 3, x is equal to 3 we have found. But even then I am telling this function is a continuous function, whatever may be the x. Third question is going to come like that. Okay, this function is continuous at any value. Okay, let us proceed for third question. Okay, third question, 4 parts are there. Let us go. Okay, see the third question, 4 parts are there, A, B, C, D. First part we have taken A, 3A. What they have written, examine the following functions for continuity. Okay, you see now, they are not asking us to find at one particular point. Say x is equal to 5, find the continuity, x is equal to 3, find the continuity. That means, see, in general, you have to find the continuity. If wherever discontinuity is there, you have to write this function is at discontinuous at this point. That means after that point, before that point, the function may be continuous. But here, such conditions we have to find. But by seeing itself, we can say that this function is continuous. Why? Because see here, what is the domain you can take? Domain, 3 domains you can take. X is equal to 5, x is equal to less than 5, x is equal to greater than 5. Now you don't take here what like we can say left hand limit, right hand limit, like not that you take x is equal to 5 one case, x is equal to x is less than 5 one case, x is greater than 5 one case. Why? Because in general you have to find the continuity here. Any one value it is continuous only. Any one value. Why? Because there is no logical controls. Greater than, less than, something is there means then we can find. But here, even then we can, by seeing itself we can say this is a simple function, continuous. But even then we will take such that limits. Okay. Let us proceed. See how I am taking the limits also. Let x is equal to 5. Okay. Let x is equal to 5. 5 I have taken, see, by seeing this 5 I have taken, here 5 is there. X is equal to 5 it is becoming. This function x minus 5, if you equal to this 0, automatically x is equal to 5 it is going to becoming. That is why I am taking 5 as the input or like domain. Okay. X is equal to 5. Limit x tends to 5, f of x is equal to limit x tends to 5, x minus 5, that is equal to, apply 5 minus 5, that is equal to 0. Okay. 0 is defined, 0 is not undefined, 0 is defined. Okay. Now you tell me slightly greater than 5 or less than 5, if you give, same 0 is coming or not? Same 0 is coming only. Why? Because see, slightly less than 5 means 5 only you are applying. Slightly greater than 5 means 5 only you are applying. That means, see, with one statement we can write here. You see what I am writing. Left hand limit is equal to right hand limit is equal to limit x tends to 5 f of x. You understand what I have written? You see, left hand limit is equal to right hand limit is equal to limit x tends to 5 f of x. Limit x tends to 5 f of x. Therefore, the function is continuous at x is equal to 5. First one case we have finished. At x is equal to 5, this function is continuous, like we have confirmed. Okay, see, we know, but this procedure you have to follow. At x is equal to 5, the function is continuous. Okay. Now, two more cases we will take. X is less than 5. Less than 5 means one number you take and you apply for all numbers. Okay. And write that x is less than 5, continuous. Again, you take one more number, x is greater than 5. There also you confirm that this all limits are same and x is greater than 5 in all area, this is confirmed. Finally, you write the function is continuous at all values. Okay. Let us proceed. Let now write down continuity at x is less than 5. Let x is equal to 4. Why 4? Because we want to check the continuity at x is less than 5. Less than 5 means any less than 5 one number you take. Don't say that 5 minus is less than 5. 5 minus is not less than 5. 5 minus is approximately, again you are substituting 5 only here. Okay. Okay. Now let x is equal to 4. Why? Continuity at x is less than 5 we are checking. Okay. See how I am checking. Limit x tends to 4. F of x is equal to limit x tends to 4 x minus 5, that is equal to 4 minus 5, that is equal to minus 1. Okay. Now again you tell me Like this, shall we write left hand limit is equal to right hand limit is equal to limit extends to 4? Definitely we can write. Why? Because if 4 minus 4 plus, even if you also this minus 1 only is going to come. This value is not going to change. Okay, you understand? Okay, write down then. Same thing, write down you then. Left hand limit is equal to right hand limit is equal to limit extends to 4 f of x. Left hand limit is equal to right hand limit is equal to limit extends to 4 f of x. Now you write, therefore the function is continuous at x is equal to 4. You want to write? No, the function is continuous at x is less than 5. That you have to write. By above we can say the function, okay, write down. By above we can say the function is continuous at x is less than 5. Okay, at equal to 5 also continuous, at less than 5 also continuous. Less than 5 means whatever may be the number you give, it is continuous. Now again, third also you can write. Third also by same procedure, but even then you write once. Continuity at x is equal to continuity at x is greater than 5. Why? Because x is equal to 5, x is less than 5, x is greater than 5. 3 areas we are checking the function. Okay, if 3 areas it is continuous, then we can say that finally this function is continuous. Okay, write down continuity at x is greater than 5. Okay, write down limit x tends to, see 7 means let x is equal to 6 you take. Why? Because greater than 5 one number you have to take. Let x is equal to 6. Okay, limit x tends to 6, x minus 5 is equal to 6 minus 5 1. Directly I have written. You need not to make that much steps. 6 if you substitute 6 minus 5 1 is going to come. Okay, now you tell me left hand limit right hand limit are they going to change? No, then you write left hand limit is equal to right hand limit, that is equal to limit x tends to 6 f of x. Okay, now what you are going to write? You are going to write the function is continuous at x is greater than 5, not at 6. Why? Because any value if you give, same thing is going to come. That is why you have to write like this. The function is continuous at x is greater than 5. You see here 3 statements you have made. The function is continuous at x is equal to 5. The function is continuous at x is less than 5. The function is continuous at x is greater than 5. That means the function is continuous at any value by seeing this. Okay. Final statement you have to write, this is a continuous function. Write down. Finally, this is a continuous function. You understand? Why? Because they are asking us to examine the continuity of the following functions. Like we have examined the continuity of the function. Examined. We have examined. Examination means not with one single step. Examination will be like this only. 2-3 steps we have to take. We have taken 3 steps. At x is equal to 5 is 1 step. At x is less than 5 is 1 step. At x is greater than 5 is another step, 3rd step. By examining all these, or else we can write finally rather than finally. After examination, we confirm that this is a continuous function. Like, okay, I don't know for how many marks it will come. You can skip some steps if you want. Okay, you can skip some steps if you want based on the questions. Based on the marks. Okay, let us proceed for B, 3B. Okay, observe the question carefully. B. Third question B, part B. Same, examine the following function continuity. Okay. F of x is equal to 1 by x minus 5, where x is not equal to 5. Why? If x is equal to 5, 5 minus 5, 0, 1 divided by 0, again undefined is going to come. Understand now? Undefined is going to come. Because undefined is going to come, that is why the function is not defined at x is equal to 5. The continuity, how it comes? Continuity is wherever the function is defined in that area, if function is continuous, then we can say confirm that finally the function is a continuous function like. Okay, that means rather than x is equal to 5, we have to see x is less than 5, x is greater than 5. In these two areas, if the function is continuous, then we can confirm that this is a continuous function. That, but we are examining, simply we are not writing, we are examining, we will examine. Okay, let us write continuity at x is less than 5. Two cases only here. Why? Because x is equal to 5 will not come. X is not equal to 5. X is less than 5, one case. X is greater than 5, one case we will take and we will confirm. Okay. X is less than 5. Let x is equal to 4. Why? Because any one number you have to take. You apply limit means, see, x is less than 5 means limit x tends to x less than 5. You cannot write. That is why at least one, any number you have to take. Say, let x is equal to 5. Okay. Now you see what I am writing. Limit x tends to 4, f of x is equal to limit x tends to 4, 1 by x minus 5. That is equal to, you apply limit now, 1 by 4 minus 5, that is equal to 1 by minus 1, that is equal to minus 1. Is it okay? Definitely okay. Now you tell me, slightly less than 4, 4 minus, if I give, same minus 1 is going to come or not? Yes, minus 4 only going to come. Slightly greater than right hand limit, slightly greater than 4, if you give 4 plus, minus 1 is going to come or not? Yes, minus 1 only is going to come. Why? Because there is no logical controls. If x is, they have written that x is not equal to 5, that's all. But there is no logical control. That means there is no change in the values. Slightly if you increase or decrease the 4. That means what we can write? We can write f tan limit is equal to right hand limit is equal to f of x, limit x tends to 4 f of x. Okay. Then shall you write the function is continuous at x is equal to 4? No, the function is continuous at x is less than 4, you have to write. Because any number if you take, it will come like this one. Okay, write down. First what I am writing, you see, observe carefully. Left hand limit is equal to left hand limit is equal to right hand limit that is equal to this one, limit x tends to 4 f of x. Okay, limit x tends to 4 f of x. But you should not write the function is continuous at x is equal to 4. X is equal to 4 we have taken, but this you have to write. The function is continuous at x is less than 5. That means at x is less than 5, any value less than 5 if you give, the function is continuous. We have confirmed. We will confirm now at x is greater than 5 also. Why? Because x is equal to 5 we should not take it. Okay. Let us proceed further. Continuity at x is greater than 5. Let x is equal to 6. Is it okay? Yes, definitely okay. Why? Because see, we are seeing continuity at x is greater than 5. X is less than 5, finish it. X is greater than 5, we will see. X is equal to 5, we should not see. Why? Because there is function is not defined there. Okay. You see, x is greater than 5 means what any one number you have to take. Why? Because you have to apply the limit. If you want to apply limit means practically one number you take and apply, then finally you confirm that for all numbers like this it is continuous like if it is continuous. Okay. Proceed further. limit extends to 6. F of x is equal to limit extends to 6 1 by x minus 5, that is equal to 1 by 6 minus 5, that is equal to 1. Is it correct? 6 minus 5 is 1, 1 by 1 is 1, that's all. Okay, now you tell me slightly less than 6 I will give. Is it going to change the value? No. Slightly greater than 6 I will give, right hand limit. Is it going to change the value? No. Then we can write like this. Left hand limit is equal to right hand limit is equal to like this. Okay, let me write. You see what I am writing. Left hand limit is equal to right hand limit is equal to limit extends to 6 f of x. Okay. Now this is over. Now you have to write continuity of the function. What we have to write? Shall we write the function is continuous at x is equal to 6? No. We have to write the function is continuous at x is greater than 5. Okay. Why? Because any number if we give same thing is going to come. Okay. Write down. The function is continuous at x is greater than 5. Now you see this function is continuous at x is less than 5. The function is continuous at x is greater than 5. But function is not defined at x is equal to 5. Okay. Now what you have to write finally, whether this function is continuous or not? Finally, continuous only. Why? Because the defined area is continuous. The function is continuous at all defined domains or defined values. Therefore, this is a continuous function. Finally, you have to write this is a continuous function. Okay. There is no discontinuity. Why? Because see, discontinuity is there at 5, but that is not defined. That is why we cannot say this is discontinuous. This is a continuous function. Like that we will write and close. Okay. Let us go for C, part C, third question. Examine the following functions for continuity. C. F of x is equal to x square minus 25 by x plus 5. X is not equal to minus 5. This is the function. We have to examine the continuity of this function. Here also you see at x is equal to minus 5, the function is not defined. That means here two domains we can take. First domain x is less than minus 5. Second domain x is greater than minus 5. X is less than minus 5, all continuity you can check. X is greater than minus 5 also, all continuity you can check. Why? Because see, if x is equal to minus 5 means minus 5 plus 5, 0 will come. Something by 0 undefined. Therefore, they are not defined at x is equal to minus 5. Okay. Less than, greater than, you can apply and see. Normally this is continuous only. Why? Because there is no logical controls here. Logical controls are there means then we can say logical control questions. I think not 3, 5th question onwards you are going to get those logical controls. Then there you can getting started discontinuous functions. Until then all continuous only, but even then as per procedure we have to proceed further. Okay. Now you take let continuity at x is less than minus 5. Write down. Continuity at x is less than minus 5. Why? Because equal to minus 5 we should not take. Less than minus 5, greater than minus 5 how to take. Okay. Write down. Continuity at x is less than minus 5. Okay, write down. Now you see, less than minus 5 means any one number we have to take to apply the limit. Minus 6. Minus 6 is less than minus 5 only. Please keep in your mind. Let x is equal to minus 6. Minus 6 is less than minus 5? Yes, less than minus 5. Okay? Write down. Limit x tends to minus 6. Minus 6. F of x is equal to limit x tends to minus 6, x square minus 25 by x plus 5, that is equal to, okay. Now apply limit minus 6 square minus 25 by minus 6 plus 5. Minus 1 will come denominator, but here 36 minus 25 is 11. Minus 11 will come. Okay. Now you tell me slightly less than minus 5, minus 6. If you give left hand limit, is this value is going to change? No. Slightly greater than minus 6 if you give, is this value going to change? No. Then what we can write? We can write left hand limit is equal, right hand limit is equal to limit x tends to minus 6 f of x. Write down first. Write down. Left hand limit is equal to right hand limit is equal to limit x tends to 6 f of x. Okay. Same thing is going to come. Left hand limit, right hand limit also at 6. But now you have to write continuity. Shall you write the function is continuous at x is equal to minus 6? No, you have to write the function is continuous at x is less than minus 5. Okay, that you have to write down. The function is continuous at x is less than minus 5. This you have to write. The function is continuous at x is equal to less than minus 5 only you have to write. Okay, that means we have confirmed that this function is continuous at x is less than minus 5. Again we find x is less than greater than minus 5. There also we will see the continuity. We know that this is continuous, but even then as per procedure we have to see. Okay, write down continuity at x is greater than minus 5. Okay, but any one value you have to take that value as, see, greater than minus 5 means minus 4 is greater. That you keep in our mind. Let x is equal to minus 4. Minus 4 is greater than minus 5. Okay. Then you proceed further. Limit x tends to minus 4. F of x is equal to limit x tends to minus 4. X square minus 25 by x plus 5. That is equal to minus 4 square minus 25 by minus 4 plus 5. Okay. 16 minus 25 by plus 1. 5 minus 4 plus 1. Okay. 16 minus 25 is minus 9. Minus 9 by 1 is minus 9. Okay. Now you tell me slightly less than minus 4 if I give left hand limit. Is this value is going to change? No. Next, right hand limit. Slightly greater than minus 4 if I give. Is this the value going to change? No. Then what you can write? You can write like this. Left hand limit is equal to right hand limit is equal to limit x tends to minus 4 f of x. Okay. Now you tell me what you are going to write. Are you going to write the limit, the function is continuous at x is equal to minus 4? No. You have to write the function is continuous at x is greater than minus 5. You have to write. Write down. The function is continuous at x is greater than minus 5. Okay, you see here the function is continuous at x is less than minus 5. The function is continuous at x is greater than minus 5. And finally what you are going to write? Finally you are going to write this is a continuous function, like write down. this is a continuous function. How you have confirmed that this is a continuous function? Because in defined areas the function is continuous. That we want. In undefined area you need not check. Why? Because in undefined area function is undefined, that's all. Okay, in defined area you have to check. In defined area any discontinuity is there, then the function is discontinuous at this point, like we will write. But there is no question of discontinuity here. This function is continuous. Okay, let us proceed for part D, third question. Okay, see, examine the following functions for continuity. Part D, f of x is equal to modulus of x minus 5. That means modulus x minus 5. Modulus of x minus 5 we can write, or else we can write x minus 5 modulus. Okay, see here what domain you are going to take. First you tell me. Here also like equal to 5, less than 5, greater than 5 you have to take, but any value if you take, this function is continuous only. Modulus function normally continuous only. Minus also it will make plus, finally final result plus always will come plus, or else 0 will come. Okay, but left hand right hand limit, any limit if you give also same thing is going to come here, modulus function. Okay, see, we know that this is a continuous function, but how to examine or prove? Why? Because the examiner wants us to do some examination, then only he may give marks to us. Then how to write it? Okay, but you see now any value you can take. 5 you can take, 5 minus 5 0. Okay, defined. See, undefined should not come, defined. And 5 plus minus left hand limit of 5, right hand limit of 5, if you take also 0 is going to come. Anyway you are going to substitute 5 only again. And less than 5, greater than 5 also if you take, the same values are going to come. Okay, then how to write this? Function is continuous, like any one value you have to take, that's all. Okay, let us take three values, like x is equal to 5, x is less than 5, x is greater than 5. Okay, and we can say that continuous function is continuous, like. Okay, write down. Continuity at x is equal to 5. Continuity at x is equal to 5. Okay, limit extends to 5, f of x is equal to limit extends to 5 modulus x minus 5, that is equal to 5 minus 5 modulus is equal to 0. Okay, now you tell me slightly less than 5 if you give 5 minus 5 0, slightly greater than 5 if you give 5 minus 5 0. That means the function is continuous at 5. Okay, but even then write down. Left hand limit is equal to right hand limit is equal to limit extends to 5 f of x. Therefore, now here we can write the function is continuous at x is equal to 5. Why? Because less than 5, greater than 5 are not yet seen. You have to write it. Therefore, write down the function is continuous at x is equal to 5. Okay, write down the function is continuous at x is equal to 5. First you write that, and we will see two more cases. X is less than 5, x is greater than 5. There also function is continuous only, but for examination we are doing like. Okay, let us proceed. Continuity at x is equal to x is greater than 5. continuity at x is greater than 5. Let x is equal to 6. Is it okay? Definitely okay. 6 is greater than 5 only. If it is continuous at 6, we can say that x is continuous at greater than x is greater than 5. Okay, function is continuous at x is greater than 5. Okay, write down. Limit x tends to 6. F of x is equal to limit x tends to 6. X minus 5 modulus, that is equal to 6 minus 5 modulus, that is equal to 1. Is it okay? Definitely okay. Okay. Now write down. Now you tell me, if slightly less than 6, if you give 1 is going to come. Slightly greater than 6, if you give right hand limit, 1 is going to come. That means, is it continuous at x6 is equal to or not? Yes. But shall you write the function is continuous at x is equal to 6? No. We are going to write the function is continuous at x is greater than 5. Okay, write down. Left hand limit is equal to right hand limit, that is equal to limit x tends to 6 f of x. Therefore, the function is continuous at x is greater than 5. Okay, not at x is equal to 6, continuous. X is greater than 5. X is equal to 5 once we have seen. X is greater than 5 we have seen. And we will see x is less than 5. Okay, in all area, if it is continuous, finally this is a continuous function, like we can write finally. Okay, write down. Write down now. Continuity at x is less than 5 now. Continuity at x is less than 5. Let x is equal to 4. Why? Because if less than 5 means any one number you have taken practically for seeing the limit. Okay, I have taken x is less than 5 as 4. 4, that's all. Okay, let us find limit x tends to 4. F of x is equal to limit x tends to 4 modulus x minus 5, that is equal to modulus 4 minus 5, that is equal to 1. Because minus 1 will come, but a modulus will make it as 1. Okay, now you tell me, slightly less than 4, if I give 1 only going to come. Slightly greater than 4, if you give 1 only going to come. That means we can say that left hand limit is equal to right hand limit is equal to limit x tends to 4 f of x. Write down. Write down. Left hand limit is equal to right hand limit is equal to limit x tends to 4 f of x. Okay. Now what you are going to write? Do you write x is function is continuous at x is equal to 4? No. You have to write the function is continuous at x is less than 5. Write down. The function is continuous at x is less than 5. This you have to write. Okay. See, now overview. The function is continuous at x is equal to 5. The function is continuous at x is greater than 5. The function is continuous at x is less than 5. Then what can you write? You can write this is a continuous function. Finally. Okay. You write that one. Finally, this is a continuous function. Okay. Finally, this is a continuous function. Like that, you can write and close this question. Okay. You understand now? Okay. Okay. Now what we do? We stop this class here. We'll do remaining questions. Why 34 questions are there? Several questions are there, and possible some steps we will skip. Why? Because same steps are going to repeat. Then you did not see again and again these steps. But in your examination, these steps you have to follow. And next class, from fourth question onwards, we will try to solve more questions. Okay. Thank you very much.